Hey there, hackers! In this episode of Tacit Sanctuary, I will solve one of the older puzzles from the 2021 season of the Advent of Code Challenge. This is a simulation exercise that is pretty simple, but if you are not careful, you can get burned by exponential computational complexity. So choosing the right data structure is really important. Of course, in Uiua, our data structure is the array, and I want to show you some interesting patterns how to transform and iterate the data, which are really the unique trademarks of Viva and other array languages. This is day 6 of the 2021 Advent of Code puzzles. The story in short is that we are exploring the ocean and encountering a group of fish. These lanternfish are reproducing over time in a specific exponential pattern, and we need to figure out after a certain number of iterations what will be the total number of fish. The input data contains single-digit numbers. Each number represents a single fish, and notably how many days will pass until the fish will spawn another baby fish. When the timer reaches 0, a new fish is born. The fish can repeat this every 7 days, and the first cycle of the new baby fish takes 9 days. We could represent each fish by their current timer. In fact, this is how we get our input data. But we can easily see that this will present performance challenges because the number of fish will keep growing, and in each iteration we would have to adjust the timer of each fish. So a different representation would be to organize all the fish according to their timer. And we only need to remember how many fish are in each timer slot. As the days are passing, each group of fish moves towards the left on the timeline, and those reaching 0 will reappear twice, at the 7th and the 9th positions. This way, the size of our data structure remains constant. After the drawing board, let's start with the online pad and implement this in Viva. First of all, I will use the sample data, which is a really small one with only 6 fish. The format is rather simple, a string that contains single-digit numbers separated by comma. If you are wondering how to work with this kind of data in Viva, make sure to check out my video about data processing. I am going to use the partition function to parse each character, which is not a comma. This is an easy way to transform the string to a numeric array. Remember, each of these numbers represents one fish and its current timer. To transform it to the target data structure that I just explained, I can use a really cool Viva trick. The where function normally gives me the indices of the non-zero elements of an array. But right here I want to do the opposite thing. Unwhere does exactly what I need. It counts how many elements I have in each index position. So it is kind of a specialized frequency counter. Now I just need to make sure that my array contains a single full life cycle of the fish, which is 9 days. So I used take 9 along with a field 0 to mark all empty positions. Now the big trick how to progress the fish colony to the next state is using the rotate function. When I rotate this array by 1, the first value is moved to the end of the array, with each value shifting to the left. And this is almost exactly what happens with the fish at the end of the day. The number of fish who are in the first position of the array are ready to spawn babies, and those babies will first spawn new fish after 9 days, so they shall appear at the end of the array. The one thing missing is that the parent fish also remain alive, and they will even be prepared to multiply after just 7 days. So at the same time when I rotate, I have to extract the first value from the array. I can do this with a fork, where the other operation is the first function. Now I have the rotated array on the stack, as well as the number of fish that must be added to the 7th position, which is now at index 6. To do this, I can use a structural under. Under is a really powerful feature that is often used in Viva, so it is worth practicing. In this case, I want to focus on the index 6, so I put pick 6 as the left side. And I use a simple addition on the right, so Viva will consume the extra value from the stack, adding it to the picked element. At the end, the under operation will automatically restore the remaining elements of the array. I hope that makes sense. To check how it works, I can add a few zero fish to my original dataset. Then you can see that after the rotation and the under operation, those zero fish appear at the 6th and 8th index of the array. So it is working as intended. Now we have seen how to transition the fish once to the next day. Let's take a look at how to do this as many times as we want. We can use the repeat modifier to do the same thing a fixed number of times. This is very similar to a for loop in other languages, where you have a constant number of repetitions. It is indeed what the task wants us to do, to calculate the number of fish after a certain number of days. So let's repeat the whole process on the sample 80 times, and sum all the elements with reduce plus. Then compare with the expected result, it matches 5934. So far, we were just modifying the data on the fly. To be able to parameterize our simulation, we can turn this algorithm into a function, which will take two arguments, the number of times we want to iterate and the array that represents the school of fish. First of all, after we parse the input and convert it to the 9-slot data structure, we can store it in a global constant with a binding operator. This removes the data from the memory stack and we can recall and reuse it any number of times. Then we assign the rest of the operations to a function. We can remove the number of repeats from here because that will come from the first argument. And we are actually done, ready to call the function with different arguments. The second part of the challenge requires us to do 256 iterations with the same method, so we can also verify if that works. And if I want to run it with the real numbers, all I need to do is open the input file. It has the data in the same format as my sample. So I just replace the string in my code and I can get the result with the same parameters. The program is very quick to run and the results are correct. Using the built-in array functions of Viva to solve this task, we were able to build a really elegant and compact solution here. I would say it's even quite easy to read because it is so short. But these tricks like unwhere or under require some time to wrap your head around. So if you didn't get it at first, I recommend to check the documentation for more examples and to better understand how they work. From these tiny building blocks, we can build really powerful algorithms. This never fails to fascinate me. Thank you for watching. If you liked the video, then please give me a like, and if you don't want to miss future episodes, then subscribe to the channel. See you around next time.